Hi everyone, and welcome to the 24th video in the Weather Unlocked video series. This video is going to be all about tornadoes. Now, tornadoes are usually either your favorite type of severe weather or your least favorite. From the different shapes and sizes of the funnel clouds to the various wind strengths, tornadoes are fascinating to learn about, however they can be extremely destructive. In fact, tornadoes are the third most hazardous aspect of thunderstorms, right behind lightning. Now, typically around 1,300 tornadoes will strike the United States, with the peak of tornado season occurring during April through June. So how do these powerful, destructive tornadoes form? Well, we're going to be taking a look at answering that in the next few slides. So most tornadoes usually spawn from supercell thunderstorms, which are persistent rotating thunderstorms that form in environments with strong vertical wind shear. Now, wind shear is a change in wind direction or speed with height. So in these top images here, you can see the directional shear, which is when the wind directions change with height. So in this particular image, if you're looking north, the wind near the surface is blowing from the southeast to the northwest. And as the elevation increases, the direction then becomes south, then southwest, and then finally west. Now in the bottom images, you can see what's known as speed shear, which is when the wind speeds change with height. So you can see in this image that the winds are increasing as you get higher into the atmosphere. Now, when this happens, this tends to create a rolling effect to the atmosphere or a rotating column of air, which is a key component in forming what's known as a mesocyclone, which can lead to tornadoes. So this strong speed shear combined with that veering directional shear is a condition that's most supportive of supercells, and you can get a general idea of what this looks like in this video. Now, watching this video, you can see that the rotating column of air that was created by the speed shear then gets lifted by the updraft in the storm, which provides both counterclockwise and clockwise rotation in the supercell. And this is where the directional shear comes in. Now, the directional shear is going to diminish the clockwise rotation and amplify the counterclockwise rotation, creating what's known as a mesocyclone. And then this, in turn, creates what's known as a supercell thunderstorm. From the base of the supercell, you can get an isolated lowering that's rotating counterclockwise, and this is going to be the location of the large area of upward motion in the updraft region, and is called a wall cloud. Now, from the base of that wall cloud, a funnel cloud can begin to form, which is a rotating funnel-shaped cloud that extends downward towards the ground. But an important thing to remember is that it's not yet in contact with the ground. And then finally, once the funnel cloud does come in contact with the ground, you have a tornado, which is a violently rotating column of air. Now we can see the descending funnel cloud because of the water droplets present, which allows the funnel to take on that whitish color of the cloud droplets. And as the air is moving, dust and debris on the ground will begin rotating and can often become several feet high and hundreds of yards wide. So after the funnel touches the ground and becomes a tornado, the color of the funnel will change depending on the type of dirt and debris being lofted. So for example, red dirt will produce a red tornado, black dirt will create a black tornado, and so on. Now tornadoes can last from several seconds to more than an hour, however most last typically less than 10 minutes. An important thing to remember is not to get too caught up on the size or shape of the tornado. As you can see in the images on the left, tornadoes can be large and wide, thin and rope-like, or might not even be visible. Now, occasionally, some smaller tornadoes can cause extensive damage, and other very large tornadoes over a quarter-mile wide can only cause light damage. So the intensity of the tornado isn't directly correlated with its size or shape, and any tornado can pose a threat to lives and property. Here's a look at a supercell on radar showing the reflectivity on the left and the velocities on the right. And you'll notice that it takes a classic hook appearance, which is circled in white. And that's caused by the counterclockwise rotation of that mesocyclone. And looking at that same cell on the velocity image on the right, you can see that that's also going to be the area where there's rotation. So where you see those red, orange, and yellow colors, that's showing where the winds are blowing away from the radar. And then those green and blue colors show where the winds are blowing towards the radar. So when we have these contrasting colors right next to each other, that's a pretty good indication of rotation in this supercell. Now, we estimate the tornado's wind speeds by using the Enhanced Fujita scale, or the EF scale, which estimates the speeds based on the damage left behind by the tornado. And this scale incorporates 28 damage indicators, such as building type, structures, and trees. And then each damage indicator has 8 degrees of damage, ranging from the beginning of physical damage to complete destruction of that damage indicator. So for weak tornadoes, or EF 0 to 1 rated tornadoes, winds can range anywhere from 65 miles per hour on the low end of the EF 0 to 110 miles per hour on the high end of the EF 1 rating. Now, upgrading to strong tornadoes, you can see speeds anywhere from 111 miles per hour on the low end of EF2 all the way up to 165 miles per hour on the high end of EF3, causing severe damage. And then finally, violent tornadoes are those EF4 and EF5 ratings, causing devastating to incredible damage from 166 miles per hour to anywhere above 200 miles per hour. Now, there is still some uncertainty regarding the upper limits of the strongest tornadoes, so you can see that the EF5 ratings don't have an upper bound to those wind speeds. They're left more open-ended. Now, it's important to understand the difference between a tornado watch and a tornado warning so that you can know what actions to take in case you are in either one of those. And a great way to do that is to think of it in taco terms. Well, when we have a taco watch, that means that we have all of the ingredients to make tacos, but we don't yet have a physical taco in our hands. However, once we have a taco warning, that means we're having tacos right now. So if you put that into tornado terms, a tornado watch is when conditions are favorable to produce a tornado. So that's the time you really want to be prepared, know where you'd take shelter if a warning was issued, and then have multiple ways to receive warnings if they are issued for your area. And then the tornado warning is when a tornado is imminent. So that's when you would take immediate action and get to shelter. Now, when deciding where to take shelter, the best options are going to be in a basement or a designated tornado shelter if you have one. But if you don't, the next best option is going to be on the lowest level in an interior room that does not have windows. Now, if you happen to be driving when a tornado warning is issued, getting off the road and taking shelter in the nearest tornado shelter or building is going to be the safest option. However, if that's not possible, as an absolute last resort, you can either stay in your car with the seatbelt on, making sure your head is below your windows, or get into a nearby ditch that's lower than the roadway. Now, these two options are definitely not the best options, but can be used as an absolute last resort. An important thing to remember is that staying under an overpass is the worst place to take shelter and is one of the most dangerous places to be during a tornado. And then lastly, make sure you're not relying on the outdoor sirens alone to alert you of a tornado warning. These are meant to be heard outdoors, so if you're inside, you most likely won't hear them. And then even if you're outside, if it's loud out or if a tornado destroys the alarm, you won't be able to hear it. So it's always important to have multiple ways to receive tornado warnings and not just rely on those outdoor sirens. So that concludes this video on tornadoes and how they form. So make sure to stay tuned for future videos in the Weather Unlocked video series.